Welcome everyone. This is the first lesson recording for IM2, October 15, 2020. We started off by doing a similar polygon review Kahoot. So if you missed it, I'm sorry. The quiz will be at the end of this class. So if you missed it because you were absent, then you need to contact me as soon as possible to make up the quiz. These were the warm-up problems that if you were here early, you were to answer, are these triangles similar or not? And we'll revisit these problems a little later on. Some announcements. Unit 3 test will be next Thursday. So that's in 1 week time. It's going to be on transformation, congruence, similarity, everything that we covered since the last unit test. And so that is the day to turn in any missing work from Unit 3. So that's the last day. Remember, I do not accept any late homework beyond the unit test day. So if you have any missing work, please get them done and turn them in. And you should also be starting to look over your notes and homework practice problems to start to prepare for the test. And review packet will hopefully be ready next class. Homework answers were reviewed during the class. I do not record them since I do accept late work. Goal for the day. We are going to revisit the similarity shortcut and using them to find the missing sides. So let's see what you remember from last class. So I want you to tell me in private chat, what are the shortcuts that we can use to decide if two triangles are similar? Not congruent, similar. Okay, and hint, there were 4 of them. The answers are, there were AA similarity. So if you have just 2 angles that are two corresponding angles that are congruent, or 3 sides that are proportional, or 2 sides that are proportional and 1 corresponding pair of angles that are congruent, and that has to be included angle, otherwise it comes under AAS or no SASS, which is not a similarity shortcut. And then lastly, HL, if it's a right angle triangle, then if you have hypotenuse and leg being proportional, then that will be similar as well. Okay, HL is an extension, so I am not going to focus too much on that. So remember from last lesson, so you know all the congruent shortcuts. The similarity shortcuts are very similar, okay, except if anything it's simpler because ASA and AAS is covered as just AA similarity. So as long as you have 2 angles that are corresponding, that are congruent, then you can conclude that 2 triangles are similar. And HL gets translated to both. This is something that you should have taken from notes you should have taken from last lesson. ASS or SSA, they are not similarity shortcut, just the same way they are not congruent shortcut. Alright, these are the notes that you should have taken from last week or last lesson. If you have not, you should pause the video and take these notes down. That just summarizes the different rules and when you are going to be using them and what to check for. Alright, so let's just quickly do these problems together. So when you have 2 different two triangles and you're given this data and you're trying to see if they are similar or not, well, what do we have? We have 44 here, 44 here, 86 here, 86 here. You have 2 pairs of corresponding angles that are congruent, that are same. That means by AA similarity that you have the 2 triangles are similar. Okay, so you should be taking inventory. That means look at what the information you're given, and then you should be thinking, okay, what are the possible shortcuts that I could use? That's AA similarity. And then from here you should be checking, are the corresponding angles matching up? And yes, they are. So the two triangles are corresponding. And remember, when you're writing the similarity statement, this is the similarity statement with a triangle symbol, and then followed by the letters of the vertices. Is similar to triangle, and then 3 letters for the triangle vertices. And these vertices needs to be corresponding, as in L matches up with U, vertex M matches up with V, and vertex N matches up with W. Alright, what about this problem? Okay, so first take inventory. What are we given? We're given one side, another side, and an angle in between. And we're given one side, another side, and an angle in between in both triangles. So then possible shortcut we could use is side, angle, side. That means we need to check that two corresponding angles are congruent, and they are by that notation of one arc symbol. And then now we have to check the sides to be proportional. That means the ratio must match. So match the corresponding sides. So we know that match the short with short, long with long. So looking at these two sides, which is the shorter side? It's the 19, between 19 and 41. 19 is the shorter one. Between these two, which is the shorter side, it's 21. So I am going to match 19 over 21, 19 over 21, and then 41 over 49, and find the ratio and look at the ratios. You use calculator, and there are two different numbers. They're close, but they're not close enough. Okay, we need to be exactly the same, and they're not. So it fails the ratio test. So it fails SAS similarity. So they are not similar. What about these two triangles? Okay, what do we have? Take inventory. Well, we have 3 sides given in one triangle and 3 sides given in the other triangle. So possible shortcut that we could use is side, side, side. Well, to do side, side, side similarity, we need to check all 3 side ratio to match. It's not good enough 2 of them matches, all 3 of them needs to match. So again, match the short with short. So which is the shortest side of these 3 sides? 35, 70, and 45. 35 is the smallest, so that's the shortest side. And for this, 6, 9, and 13, 6 is the shortest. So match short with short, so 35 over 6. Medium with medium, 45, and the medium side is 9. And then 70 and 13. And then find the ratio. You can use a calculator. Okay, so 2 of them match, but 1 of them does not. Okay, so that's not good enough. They all have to match. So it fails SSS ratio check. So the 2 triangles are not similar. What about this problem? What are we given? We are given 2 sides and an angle that is not included. 2 sides and an angle that is not included. Okay, so what are the shortcuts? Remember, angle side side is not a similarity shortcut, just the way angle side side is also not a congruence shortcut. So there is none, so there are no shortcuts to use, so they are not similar. We can't conclude that they are similar. Alright, so let's move up a notch. Okay, so what if you're given these 2 triangles? You have 84 degrees here, 84 degrees here. So between the top triangle and the bottom triangle, are these 2 triangles similar? That's the question. Well, we have one pair of congruent angles, corresponding angles that are congruent. Do we have anything else? Yes, we have the vertical angles. They're called vertical angles, are always congruent. That means we have angle here that are one pair of angles that are congruent and another pair that are congruent. So by AA similarity, the 2 triangles are similar. What about this one? Okay, we're moving up one more notch. Okay, so level 2, when you're given these 2 triangles and you have many different side length given. So 55 is this side length, 16 is this side length, this is 24 here, and 42 here, 28 here, and 33 here. Okay, so we are trying to figure out, is this triangle, the smaller one inside, is that triangle similar to the bigger triangle, the one that's outside? To do that, the easiest way is to separate the triangle. So if I redraw the smaller triangle inside, here we go, that's what it is. And then the bigger triangle outside is this. And you can just figure out the sides, okay? And what do we know? Well, we know that this angle and this angle, they are basically the same angle. We just sort of move them apart, but they're really referring to the same angle. So by definition, these two angles are congruent. So then we need to check. We're given a whole lot of different sides. Okay, so we need to check, what are we given? Well, we can in theory do side, 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 but we already have corresponding angles that are congruent. So we just need two more pairs of ratios to be exactly the same. It's because side, angle, side would work for us. So let's check this side. What is the length of this side? It's 16 plus 24. What is the length of the corresponding side? Is this, that's 24. So, and KF corresponds with EF, right? So those two match up. They're the two corresponding sides. Then we're going to come up with the ratio. Okay, so that's 28 plus 42. So 28 plus 42, that's the red side here. Okay, so that's 28 plus 42 is the red at the top, and 42 at the bottom is this side. What is this length? 16 plus 24, that's the top, the numerator number, and that matches up with 24. And what are the ratios when I use calculator? That's 5/3 and 5/3, so they both match up. So I don't even have to check the third side. Why? Because we have already established that two angles match up. Okay, so yes, by SAS similarity, the triangles are similar. Okay, can you check with SSS similarity? Maybe. Okay, so if we could certainly do it again. So 55 over 33 is, again, that's 5 over 3 as well. Okay, but we intentionally did not check this as SSA, because remember, SSA is not a triangle similarity, while as SAS is. All right, good. Then let's try this one. Okay, what information are we given here? Well, we have these two arrows. What do they mean? It means that line ST and KL, they are parallel to each other. And so again, I want to separate these two triangles, and the one in the top and one at the bottom. Okay, now we know that the two triangles, the bases are, okay, no, actually before we do that, what do we know for sure? Well, this angle matches up with the angle M here, and matches up with the angle M here. So we know that these two pair of angles are corresponding and are congruent because they are the same angle. That means it's going to have equal measure. What else do we know? Well, we know that this line and this line are parallel. That means, what are these two angles called? They are called, the corresponding angles of parallel lines. Okay, they are in the same relative position of parallel line intersection. So we know that they are congruent, and so we have angle and another angle that are corresponding and congruent, and that's all we need. So by angle-angle similarity, the two triangles are similar. And then lastly, there is another example, but I will continue in the next recording.